Today we learn how to graph parent functions. A parent function is a function that has a general shape. The shape is then manipulated depending on the values. You have to memorize these shapes. I'll say that again. You have to memorize these shapes. If you bring me a question over how it's graphed, but you don't know the shape of the graph, then I really cannot help you because you have not memorized the shape of the graph. Now, I understand that MathXL is easy enough to kind of push some buttons, but you also have to remember that you have to do the test or quiz on paper. So make sure you know it. Don't try to get over on me. Just make sure you're actually learning it, and then again, be as efficient as you need to on homework, but make sure you know it. The absolute value function has 3 key points. First one is at 0, 0. The second is at 1 over 1 up, back 1, 1 up. Looks like a V. And so the absolute value function, the reason I remember what the absolute value function looks like is because absolute value starts, one of those words starts with a V, and notice that that's the shape of the graph. The key thing is the 3 key points. 0, 0 is your home point. Over 1, up 1, back 1, up 1 gives you what you need there. So sketch that for yourself. Write down whatever notes you need and make sure you study it. The x squared function, which is a parabola, but we'll get into that later, is still 0, 0. You'll still go over 1, up 1. You'll still go back 1, up 1. The difference here is that it's shaped like a U, so it's going to be more like this. It's a parabola. Again, you saw this, I believe, in chapter 9 of your work. X to the third is similar, but again, it starts at 0, 0, which is why these are all very good, because all your home points are 0, 0. But x to the third is different. The cube 1 to the third is 1. Negative 1 to the third, though, is negative 1. And so what x to the third does is it takes the x squared graph and it flips this side down. So instead of looking like a U, it's going to look more like this. All right, so again, x squared is a U, x to the third, you just drop that other side down. And as you practice, you'll get better with this. When you talk about the square root function, this is different. This is the one where you want to make sure you remember some things, and it comes down to your perfect squares. The square root of 0 is 0, so 0, 0 is still your home point. The square root of 1 is 1. There is no square root of 2. There is no square root of 3. There is a square root of 4, which is 2. And so that is how you find your key points. It is a half U because there is no square roots of negatives, and this calculator will prove it to you. Square root is second x squared. Square root of 4 is 2, but the square root of negative 4 is what we call a domain error. Remember, domain is what you put in. Your calculator is saying that whatever you put in is wrong because you cannot do the square root of a negative. This is your square root function. All right. Third root is not third power, but it's similar to the third power because you do go 0, 0, up 1 over 1, back 1, down 1. But in this case, remember the x squared had this shape. I'm sorry, square root had this shape. The cube root is actually an S shape. And so that's what you're looking at. So today your main job is to learn how these graphs are shifted up, down, left, and right. Each of these graphs, again, has a home point at 0, 0. That is the point you'll shift from the f of x function. So let's look at this. Outside shifts. Think of the outside shift the same way we do when we graph lines. This tells me to go up. This tells me to go down. All right. The same rule applies when you are graphing those things in terms of your grouping symbol. So if it's outside the grouping symbol, it's just like graphing a line. So if you were looking at this, this would go 3 up. So it would take that parent function that we know and move it 3 up. This would take that parent function that we know because it's not with the x squared and move it 5 down. This, because it's not in the grouping symbol, would move 1 down because, again, we did that with our stuff to make sure we knew how to do it. We simplify that with f of x plus k. Notice that the k is outside of the parentheses, and so whenever it's positive, it moves up. Whenever it's negative, it moves down. Give me a second. My computer just said it's about to die. Inside shifts are a bit tricky, but once you understand why, it's a bit simpler. So looking at the concept, we have an inside negative 2. We have an inside net positive 5, and we have an inside positive 4. On the inside, you will do the opposite of what you expect. So when you see a 2 on the inside. First off, it's left and right, but you would view this as a positive 2, and in terms of left and right, positive 2 would go to right. You might want to write these down because the inside is the hard part. You haven't worked with these a lot. Actually, you saw it last year, but these are where I go. So again, this 5 is on the inside, but I would view it as a opposite, which means negative 5, and in terms of left and right, this would be 5 left. This 4 is also on the inside, but I would view it as a negative 4, which in terms of left and right would be 4 left. Why? Because what value of x would make this 0? Positive 2. So positive 2 minus 2 would make it go away. What value would make this 0? Negative 5, which is why you view it that way. What value would make this 0 would be negative 4. So that's part of why you use that negative, because again, it's the opposite. So this shift occurs because these values are cause the group to equal 0. And again, because of that, we use the opposite of what our instincts tell us. Again, we simplify this notation by using the format x minus h. So when h is connected to a negative, the graph shifts right. When h is a positive, the graph shifts left. I don't know how to exactly explain that to you without making things even worse, but let's just go ahead and get to the graphs and see what we can do, because remember, these are your test questions. So let's see. If you're asked to graph this function, x to the third plus 2, first off, I have to remember what the x to the third graph looks like. So I might go off to the side and say 0, 0, it goes up over, I believe x to the third is this one. But I do know that this plus 2 means it's going to go 2 up. So there's my home point. Over 1, up 1, back 1, down 1. And then I do what I was trained to do, which is I draw that shape the way it's supposed to be. That's it. That's why it's called parent functions, because once you know the shape of the parent function, everything is done. On this one, this is a inside number, which means I view it as a positive 3, which means 3 right. And so what I do is I take my home point, which is 0, 0, and move 1, 2, 3 to the right. I then follow the rules of the absolute value, because that's the parent function we're looking at, and I go over 1, up 1, back 1, up 1. I remember it's an absolute value, which starts with a V, and I remember that absolute values look like a V. That would be my graph. Remember, this lesson is not meant for you to master it. It's meant for you to watch, take notes, and then practice. But again, I think you can do it as long as you take your practice seriously and you ask as much as you need to. You can't really bother me unless you're just not working. And then you actually ask me all the questions at once. So as long as you're kind of hit me with questions as they pop up, that's fine. What I don't like is whenever you wait 4 days in a row to the day before the test and you hit me with every question for the whole week, because I really can't help you at that point. I know about the realism. So in this one, we're talking about the parent function of x squared, because you see the squared, which means it's shaped like a U. And again, maybe you don't know that, but at some point you should. Then you recognize that this moves 3 up, because it's the outside 3. We also understand this is a positive 1, which means 1 right. So from here, I want to go 3 up, 1, 2, 3, and 1 right, 1. There it is. I then follow the rules for x squared, which I remember looks like a U. I go 1 over and up, 1 back and up, and I draw a parabola. On the next one, I recognize that this is a root of third root of x, because that's pretty much how it's built. So that's your parent function. If you remember third root of x, it's the one that shapes like this. So the main thing you want to know is the shape. After that, you say, okay, this goes 1 down, because that's your outside value. This is viewed as a negative 2, which is 2 left. So I want to go from home, down 1, back 2. That's my home point. I then remember what it looks like. I go over 1, up 1, back 1, down 1, and remember what I do is this. You are not being graded on whether your graph is perfect. You are being graded on whether your home points are in place, because I need to see those home points, and whether the shape matches. You don't want to do that one for x or third root of x, because that's a different graph. All right, but I need to see on your assessment all 3 of those points. I need to make sure you understand the home points, not just the graph. So what some people like to do is be slick and they just go, you know, here it is, and they draw a graph over there. Well, I don't know where your home points are because I can't see anything. Here, I know that this is a absolute value of x, which means it's shaped like a V. I know this moves 2 up. I know this, because it's inside, is used a -1, which is 1 left. And I should at least see stuff like this on your paper, because unless you've shown me you've mastered it or you're just that good, it should be a thought process involved some way. From there, I go 2 up, 1, 2, 1 left, which is 1, because that's what that's telling me to do. And I remember absolute value goes 1 over, 1 up, back 1, 1 up, and it's shaped like a V. There we go. And then the last one is based off of the square root of x, which is the one where I have to do the 0, 1, and 4 thing, because I'm thinking about the square root of a number. But the bottom line of that is this goes 3 down and 1 right. So 3 down, 1, 2, 3, 1 right is here. That is my 0, 0 point. So you have to practice the square root one, because it's really weird. That is your square root of 0 equals 0. Then you say the square root of 1 is 1. There is no square root of 2. There is no square root of 3. But there is a square root of 1, 2, 3, 4. And the square root of 4 is 2. That is the trick with your square root function, is remembering to do that. That would be your graph. Also remember that there is no bottom half to the square root function, because you can't do the square root of a negative. So for example, you notice that it starts at x equals 1, because if I went to x equals 0, as soon as I put a 0 in here, 0 minus 1 is negative. It breaks the rule. Everything is broken. Just make sure you're practicing efficiently. Keep in mind, the break that I gave you last chapter is not going to be the same. That was just to make sure that we made up for that tough first week. Whatever tests you take are going to have to be made up. They will not be replaced like they were, I believe, at chapter 1. You need to make sure you do what you have to do. So outside of that, I'll talk to you later, and good luck.